12.1 Force. In physics, a force is anything that is considered to be a push or a pull. The symbol that we use for force is capital letter F. And the unit for force is the Newton, which is shown with a capital letter N. Force is a vector quantity, which means that it's not just how much the magnitude is that matters, it's also how far and which direction you're pushing or pulling. There are two categories of forces. The first is more familiar. We call these forces action by contact forces. And these are the forces that are pushes and pulls that you and I encounter most of the time. An action by contact force is when a force is transferred between two objects that are touching each other. They're actually in contact to transfer the push or pull directly from one to the other. The second category of force, action at a distance forces, are much more strange and hard to explain. Action at a distance forces are when force is transferred between two objects that are not actually touching. The objects could be very far apart and still exchanging a push or pull force. For example, friction is an action by contact force. The contact is caused by the contact or the touching between an object and the surface it's resting on, or the ground. On the other hand, gravity is an action at a distance force. You don't actually need to touch the Earth to experience the force of Earth's gravity. If you're skydiving or in orbit around Earth, you're not actually touching the Earth, but you still feel the pull down towards the Earth. This is gravity. And gravity can happen at a very far away distance from the object. For example, the Earth is orbiting the Sun due to the Sun's gravitational pull, even though the Sun and the Earth are very far apart. This next section, I'm going to explain to you several common examples of forces. The first is the force of friction. Force of friction is symbolized by capital F, little f, where the little f is a subscript. It's caused by the rubbing between two surfaces. Smooth surfaces transfer less friction than rough surfaces. Force is a vector, so the direction is always important. The force of friction is always directed away from the direction of motion. So in the picture in the top corner, for the two people sliding down hills, friction is directed away from the direction of motion. The force of gravity is another very important force in physics. The force of gravity is the attraction between two objects or any two objects that have mass. For example, the Earth and the Sun both have large amounts of mass, and as a result, they have a gravitational attraction between them. The more mass an object has, the more it can pull with gravitational force. On Earth, gravity is always down. When you're off the Earth, direction of gravity depends on where you are. But for objects on the Earth, we can always use down as our force of gravity. Weight is another term for force of gravity. Sometimes we use weight and mass interchangeably, but that's not actually correct. Weight is actually a kind of force. The force of gravity, F subscript little g, is weight. Here's a new force for you. The normal force is always present and you experience it at all times during your day. The normal force is the force that counteracts the force of gravity. If it weren't for the normal force, you would be falling all the time. Something has to counteract gravity so that you don't fall. But because it's invisible and you're not falling, you don't tend to notice it. When you stand on the floor, the force of gravity is pulling you down, pushing you into the floor. And the normal force, or the floor, pushes back upwards against gravity, so that way you don't fall. The normal force, F, subscript big N, is always perpendicular to the surface you're on. And points away from the surface. The normal part of normal force, the N, is because normal in math and physics means perpendicular. So normal force is always perpendicular to the surface. We also need to remember that it points away from the surface. And this makes sense because floors push. They can't suck you in. Floors can't pull, they always push. So for the tire, weight is pulling it down. The normal force is coming out of the surface perpendicular. For the skier on the hill is slanted. So the normal force, perpendicular to the hill, is also slanted. The force of tension is the force in a string, cable, or rope used to pull or suspend an object. Tension is always directed away from the object. This is really important because you're going to need to get the direction right for tension. But if you think about it, it also makes sense. Ropes really only can pull, so it really only can pull away from the object. Ropes can't push. You can't push an object with a rope. So ropes can pull, but they can't push. The applied force is our final force. We write this as F subscript capital A. Fa is the general term for any other push or pull on an object. Now, the net force isn't actually a type of force. It's sort of like saying, I have all these forces acting, now I'm going to total them up. Net is a word for total. F net is the combination of all forces acting on an object. Since force is a vector, net force is found using vector addition. You have to combine all vectors considering their direction, so x and y components, and you have to think about angles as well. So in this diagram above, we've got four forces, A, B, C, and D. F net is the vector addition of force A plus force B plus force C plus force D. And you have to take directions into account when you're doing this vector addition.